Sultani. I'm one of the 4th grade students of توسط بهمن of Ankara Institute. Today I want to talk about a topic which is related to mathematics that could interest your mind somehow. But before I go through my speech, I want to introduce you to the most misunderstood guy of the world, which is mathematics. Well, I know that most of you hate mathematics because it's kind of complicated. But if you have a deeper look to the topic, you can understand that none of the things that you have in your hands, like, I don't know, your iPhones, your iPads, your PlayStations, Xboxes, they haven't came from the air. They're all mathematically based. So before we be a lot judgmental, we better know it first. So why do we learn mathematics? Here's the question. Essentially for 3 reasons, which is calculation, application, and inspiration. Unfortunately, most of the mathematics that we learn in school are not effectively motivated. So that's why when most of the students ask us, why do we learn mathematics? They usually hear that it's kind of needed for an upcoming exam, for, I don't know, maybe a mathematics class. But wouldn't it be great if they heard that mathematics is something beautiful or it excites the mind? So, unfortunately, most of the people are not in a position to understand the beautiness of mathematics. Because of that, I want to introduce you a topic about mathematics, which is the Fibonacci sequence. As you can see, Fibonacci sequence was invented by Leonardo Pisa. He was born in Italy and he died in Italy. And here's a little biography of him. If you're interested, you can look it up on the internet. So let's go through the sequence. As you can see, it's made by a simple calculation. 1, 1, 2, 3, 5, 8, 13, and so on. How does it work? As you can see, if we add 0 to 1, you'll get 1. If you add 1 to 1, you'll get 2. If you add 1 to 2, you will get 3, and so on. The interesting thing about this sequence is kind of complicated. I just want to tell you some points about it, and I'll leave the rest to you. So let's square the numbers. 1 square is 1, 1 square 1, 2 square 4, 3 square 9, 5 square 25, 8 square 64, 13 square 169, and so on. To play with the numbers, let's add the numbers together. If we want to add up this part, we will get 6. If we add up this part, we will get 15. And if we get this part, we will get 40. Well, as you can see, none of these are a Fibonacci sequence member. But I will show you that they are hidden deep inside of it. What is 6? 6 is 2 times 3. 15 is 5 times 3. And 14 is 5 times 8. Well, as you can see, these are all the Fibonacci sequence members. As another example, I can introduce you to the Fibonacci-based squares. If you want to add the square type of numbers, To calculate it so quickly, we're going to need a calculator. But what if we don't have it? If we want to just make the solution, just find the solution in a short time, we can use the Fibonacci sequence. As you can see, there are the square type of Fibonacci members. When we add it together, we will get 8, the last number, and product it with the next Fibonacci term. And some of you might wonder, why is it like this? So I can show you by drawing a simple square. We have a 1 by 1 square here. If we draw another 1 by 1 square, we will have this. So another 2 by 2 below it, 3 by 3 next to it, 5 by 5 below it, and 8 by 8 next to it. So by these squares, we have a giant rectangle. So I'm going to ask you a simple question. What is the area of this rectangle? Most of you would like to say, by adding up the numbers here, we have 8 and we have 13, right? And as all of us know, the area of all the rectangles is width find the area of that by adding the areas of each single square, which is so these are both the areas of the rectangle. The last thing I want to tell you about the Fibonacci sequence is that we all face this in the nature. For example, the number of all of the spirals on a flower is a Fibonacci sequence. Our fingerprints or a snail's shell. The other thing that I want to introduce you is the phi. We call it the golden ratio. Where does it come from? The golden ratio comes from dividing each set of Fibonacci sequence to the preceding one. For example, like this. If we do it, we will get closer and closer to a constant number. And that constant number, the constant ratio, is the golden ratio. And we can easily see it in the nature. For example, the symmetry of our faces, it's all based on this ratio. Or the size of our bones, they are all based on this. Everything natural, everything related to nature has the same function. But not this guy. Well, thank you for listening. I hope you enjoyed your time, and I hope that it would be a trigger for you to go ahead and know this poor guy a little bit more.